Hey, it's me, Steve. It is March 12th, 2017. Time is 17:35, and the temperature is 30 degrees Fahrenheit, which is about -1°C. Today, actually, I just said that I am going to talk about measurements. And, being in one of the few countries in the world that still uses the imperial system, I actually switch back and forth between the two a lot. But I wanted to talk about why, like as a geologist, I am kind of hooked, at least for distance-wise, on the imperial system, and I'll get into that later. But I just want to say something really quick. There's two types of countries in the world: those that went to the moon and those that use metric. But anyway, that's just a bad joke, because obviously NASA's always used the metric system. But anyway, okay, first I'm going to go over volume. Now, when I do volume, there's not a lot of volume. I use percentages a lot. I don't really use direct numbers because they're hard to determine in the field. But when I do use volume, I tend to stick with the metric system. Oh, and by the way, just so you know, I'm on LSD today. Not the drug, the road. I'm in Chicago, heading back in Lake Michigan's right over there. But anyway, okay. Anyway, I tend to use the metric system. And the beauty of the metric system is that volume can convert to area pretty easily. Like 1 milliliter is equal to 1 cubic centimeter of water at, standard temperature and pressure. You don't get that with the imperial system. 1 ounce is not equal to like a pint or anything like, or 1 ounce is not equal to 1 cubic inch. I mean, nothing like that. Okay, so because it's kind of random. But when it comes to volume, I do prefer the metric system, and I'm going to give you a little hint for anyone who's converting. I'm hoping I'm doing this from memory correctly. All this is going to be from memory, because like I said, I switch between the two a lot. But if memory serves me, there's about 30 milliliters in 1 fluid ounce. There's about 1 liter or half a liter, 500 milliliters, is roughly a pint. It's a little less than that. I think it's 470 something. I forget off the top of my head. And there's 2 pints in a quart, 1 quart, and there's 4 quarts in 1 gallon. There is about 3.8 liters in a gallon. So not quite 4 liters, but it's close. And that's like the extent. Like I said, I'm a lot better with distance than I am with volume. But let's see. Okay, might as well just get into length and stuff and distance. Now, I'm still kind of hooked up on the imperial system when it comes to distances for what I do, and there's several reasons for that. The way we do our coordinate system, we're getting away from this, and I usually use GPS. I use decimal conversions. I don't usually use the minutes and seconds. It's too complicated to convert. So I just go directly with decimals. My GPS receiver's in that mode. But on the older maps sometimes, and if you go into older geology publications, they use something called township and range, which is like you get a township and range, which would be about 6 by 6 miles, and you pick a section which is within that. Then you do the northwest. You just keep getting smaller and smaller blocks till you get about the area you want. We've kind of, like I said, abandoned that in the past 10 years or so. Even the USGS topo maps these days don't have township and range on them, but the older ones are still online. And when you use township and range, obviously they're all based in miles. And at the latitudes I usually work at, which is between 45 degrees north and about 49 degrees north, sometimes 50, the mile is just a better practical use when you're using a quadrangle scale map, well, 1 to 24,000 scale. At these latitudes it works really well, kilometer not so much. But I'm also hooked on the imperial system when it comes to feet, because when you're in the field making geologic measurements, like at an outcrop face, that's not much larger than human scale, or it might be 50 feet tall or 100 feet tall. The foot, for describing it in detail, is a much more useful unit than the meter. There is 3.28 feet, I believe, in a meter, not 3. So it's a little more than a yard, 3 feet a yard. So they're not exact conversions, and I'm going to come back to that point in a little bit. But the foot is 12 inches, yay, about. Okay, and when you're describing strata in detail, beds are usually smaller than a foot. You have thin beds, medium beds, thick beds. Then you have laminations, which are smaller than that even. But when you're describing beds in an outcrop, the foot is just much more easier unit. Now, I don't use, when I describe I don't do like feet in inches. I won't say something is 6 inches long. I'll say it's 0.5 feet. When I use feet, I divide it into tenths and hundredths. And I think a hundredth of a foot is roughly 3 millimeters, something like that, if I remember correctly. So the foot, when you're just describing strata like that, is just a much more easier unit to work with. And I've run into problems before submitting papers, and I'll put everything in imperial, and then I get it says you can submit your paper imperial measurements, but everybody uses SI, fine, whatever. So I just convert it all anymore. But if you look at my field notes, they're all in imperial. And you got to be careful too, if you're not if you're working outside of the U.S., or if you're from outside the U.S. and you've grown up with metric, but you're working in the U.S. and you're looking at old USGS publications, not that old. Everything before like 1985 is pretty much in imperial units. There's some that aren't. But between 1985 and about 1995, the USGS started giving everything in both or just in SI units. But here's the thing, when you read those, you got to be careful. They didn't do exact conversions. Like if they say in that time span, if they say something like a geologic formation is 100 meters thick, they mean it's 300 feet. Not 328 or 330, because they just divided by 3. I don't know why they did this. I see it a lot. And the only reason why I ever caught this is because I would go make my measurements in the field to confirm the thickness, and I might get it a little thicker, and I'm like, this isn't 100 meters, so just a word of caution. After 1995 or so, they pretty much have accepted, SI, and they know that, people who do publications now for the USGS no longer assume 100 meters equals 100 feet, because if some formations are extraneously thick, like, you get the Frida sandstone in the UP, which can be about 15,000 feet thick. So if you just say it's 5,000 meters, you're way off in your thickness. So be careful with that when you're looking for that. Trying to think of something else about measurements. And of course, living here, everything's in miles. I go to Canada. It's not that hard to convert, really. You can think of it this way for distances. You ever see a lightning bolt and then listen for the thunder? If you count 1 Mississippi, 2 Mississippi, 3 Mississippi, not that fast, but if you hear between the lightning flash and the thunder, if that's 3 seconds, that's a kilometer away. 5 seconds is roughly a mile. Okay, so you gotta just remember that, and that helps. And it's not really, distance isn't as difficult to convert from imperial to SI and vice versa as volume is. So, it's like, just as somebody who goes to Canada a lot and stuff like that, I know 30 miles is very close to 50 kilometers, which would mean 100 kilometers is really close to 60. It's actually something like 62.1. So that conversion isn't difficult. You just got to remember what it is, and And like I said, I'm never gonna go switch strictly to metric, especially when it comes to measuring geologic units. Like I said, I've grown up with imperial. I've grown up with both of them, but it's just like I said, the imperial, when it comes to measuring strata, is a much more useful unit. And the field museum is up there. I haven't been there in a couple months, but anyway, I hope you learned something and my ramblings didn't confuse you too much. Have a good day.